Hello everyone! It's the first episode from Mega Power series. Today I want to show you high current DC connectors and cables. Let's get started. We have a nice selection of cables, different sizes and different rating. Let's look at the bigger one. High voltage link, 150 mm square, fully shielded and rated up to 1500 volts, which means 1.5 kilovolt. This cable can transfer more than 1 megawatt of power. Here's what it looks like inside. I cut the cable to show you how it's made. This is what it looks like in the cross section. 150 mm square of pure copper plus insulation, shielding and external insulation. As you can see, connectors are molded to these cables to provide very high weather protection and mechanical strength. Let's look on the other sizes. Voltage rating is again 1500 volt DC and size this time is 120 mm square. Single core conductor of this size can handle up to 500 amps. Silicon insulation is designed to work with relatively high temperature. Plus, high purity copper reduce losses and voltage drop, which minimize the heat generation. That's the big difference between the single core and multi-core cables, because single core cable could dissipate much more heat. If you got a multi-core cable, the maximum current will be much lower. Always check the specification of the product, because different manufacturer could use the different materials, and that could affect the maximum rating. Let's talk about connectors. For that high current and high voltage, we need special connectors. They need to provide very low resistance connection, good electric insulation, very good mechanical support, moisture protection, and finally some safety features like locking and H-Wheel. As you can see in this case, to unlock is required two operations. You need to slide the plastic bits and then the press unlock, and then you can pull the connector from the socket. And here, deep inside the connector, you can see two small pins. That's the H-Wheel. H-Wheel is the special electrical loop which is connected, and the loop is closed when the connectors are connected. When any of the connector it will be disconnected, that H-Wheel loop will be open and send the signal to the control to open contactors. To avoid the unplug the connector under load, because that could create a lot of arcing, especially with the DC current. And now I will show you H-Wheel in action. Okay. Now, polarity doesn't matter, but looks better. Black to black, red to red. Now, when I connect this, see, it's going, nothing. And need to be pushed really to the last moment. And now, it's connected. Probably you can hear that. But then I pull even a little bit. Still, main conductor will be connected. I can show you that. But it's not pushed to the end, and the H-Wheel is open. That's the safety mechanism. Because with H-Wheel it's not, if this is not pushed properly and it's not locked, it means the main conductors will keep open and it's no power, no possibility of power. Even if someone accidentally pulled that, before you disconnect the, sorry, it's really hard. And still main conductor is connected, but circuit is open. And this means the BMS or the safety device will open main conductor. And it's no risk when you pull under load and create the arcing, and you create any risk of life or damage or whatever. How the connectors looks inside is, as you can see, is massive. That's the massive, all the conductors come. That's a slightly different size, but different cable is damaged. It was crimped, not correct. But you can imagine it's going there, and the crimping device is squeeze that to provide really great contact. But all the surface is just connecting and touching the. It's really tight going to the connector. 70 mil square, and the maximum AC voltage is 600 and DC is 1000. This one is 1500, 1.5 kilovolt. This is the 1 kilovolt DC. Attention, high voltage. Any orange cables in the all electric vehicles, you can find the orange cables, which will be definitely to that rating in electrical. 70 mils. Oh, sorry, this one is 50 mil. This one is 70. Slightly, it's not a huge difference. The same voltage rating, and definitely different current rating for depend on the size. Because you can find many different size, shape. That's the angle connector, and it got that locking mechanism which clamp. To open it, you need to pull this. Yeah. Now press that, and you can release. When you and only you can open and close when it's like that. You see, and it's going. When you're closing, when you press, when you're closing, that mechanism is locking. On the sides, you've got the bolts, and it's locking like that. It's lock from the top, and then you push this, which lock completely. Now, even if you accidentally push, it's nothing happen. You need to unlock, then press here, and then pull this lever up. Okay, what is coming with this set? Main pins. That pins is going to the conductor. That looks like 50 mil, 50 square mil in total. It's pretty shiny because it's silver plated. That's the 50. It's going on the main conductor. Then you got the like extra rings. That's for the shielding. That's for the for just the gasket. You can see it's also aluminum foil, and then shielding. When it's going to the connector, as you can see, it's going. Sorry, I need to take the tape. Yeah, this is going to the end, and go the next locking stuff. But see what was really that bit is going there. and you need to press deeply with the whole conductor, and that gasket will seal. Yeah. And that is going on the top. It's really tight, must be tight. And then you lock this like that. And now it's really sealed, waterproof connection. It's normally rated to the IP68. And you see the gasket around is really tight. When I pull, it's going. Of course, this will be like that on the end, and the shielding is only finished here. But of course, that's a brand new connector. They are really expensive, and I can't really show you how to crimp and how to use it. Maybe one day I'll find some connectors which I can use, but now you can see how it looks like. Yeah. And it's going that way. When you press, it will connect that metal bit around. That's the shielding. And this shielding is also connected here. That's a separate internal. That's the main current going. That's the shielding. Shielding is connected. Again, slightly different. Full metal body. It means the shielding is connected to the body. And there's no press. That's you can call the heavy duty, more heavy duty. Got a gasket here, which will seal again against the cable. Is sitting really tight. You can see. And got also similar rings for similar rings for shields and for the main conductor. That is also 50 mil and looks completely different. That plastic bit on the center, some people thinks is just the pilot pin which help you to connect the connector, but is not. This one is just the what we call finger-proof cover. It means that plastic bit, it's of course insulated and stop some not smart people put the fingers inside the connector. Theoretically, when it's unplugged, the H-wheel is broken. It shouldn't be energized, shouldn't be any voltage. But still, the regulations required that us make this finger-proof. It means not enough space to put your finger there and kill yourself. That two pins are connecting the H-wheel. When it's going, when you see here, of course this one is bigger, this one is smaller. When it's going, those two are those contacting just the bridge, that two small pins there. And that provides you contact for, you can see is here, that metal bit. And that's how it looks like. And you feel like that. this way. Proper position, of course. Yeah. And then the connect shield to the squeeze. Then is the gasket, rubber gasket. No, sorry, it's not rubber, it's the silicone gasket. And the end, you just twist this together. And that's it. They are really complicated for just the connection, but this provides shielding, provides edge view, and unfortunately, because of the size of the materials, of the really high precision, and as you can see, it's a lot of components. Simple plastics, but they need to really be precise, and assembly processes is also complicated, and this means it's unfortunately not cheap. They are really expensive cables, of course, because of the copper. Look how much copper is this. The guys which collecting scrap metal will be happy to find cables like that. That's heavy. That is really heavy stuff. It's like, to be honest, 2 kilograms with the connectors and all this plastic. It's 2 kilograms. But yeah, it's really a lot of metal, and the copper, it needs to be really high quality copper, low resistance copper. Okay, now the smallest cable in my collection. As you can see, just remove that silicone shield. It's internally foil just for the separation. Just clear film. Yeah, just clear film for the separate shielding from the silicone. But that is more important for the process when they mold the installation. Then we got the shielding, like always, in those cables. Aluminium foil, like second layer of shielding. And in this case, we have 3 conductors. That, of course, is really low current, and the spec on the cable is 600 volt AC DC, high voltage. I'm not sure it was on camera because that gasket was here, around, just below that. And now will be the tricky part. No worries, is the scrap. Fortunately, many times it's just the one-time operation, and always you need to be careful when you do the new connector, because it's difficult So you can see that part is now the ring on the top, which is crimped. As you can see, the shielding is everywhere in those devices. Safety first. The people which say the DC equipment is not the safe. See the one side. Another. And as you can see, the shielding is going again on the ring and is going outside. That's what is really interesting. You got the even shielding on the H wheel, because that two wires here that's the H wheel, and H wheel here as you can see, that's the two pins are H wheel, and it's going here, and that's the end of the H wheel. That's the end of the H wheel. Those two. And the last one is just a smaller brother. It's exactly. That's a really small, much simple locking device, because you just pull, just use the force to clamp, to lock and to unlock. Because it's really low current. As you see, the conductor is much smaller compared to the big brother, and only 16 mil. In the current is much lower, and this locking is just simple, just like that. And now we got separate. That's how it looks like without. Got again the gasket, external gasket. That's the H wheel, that metal bit here. That's the H wheel on the both. And main main conductor, and of course shield. Here you can see the difference. That's the same, exactly the same series, but you got the V and X, that's the keyway. And the keyway, you got a different color. This one is going right, no problem, because this is the same keyway. And this one, see, because that keyway is not really fit. No option. And let's look for the next one. You can see the pilot, H wheel. H wheel is only on the one, because it's going as the pair. This means but just a single H wheel. And I'll show you how this is going. As you can see, is the also keyway. It must be exactly the same keyway. Yeah, going like that. But you need to unlock, and you can press, and then press and just pull down, and it's locked. That piece is completely locked here. Then when you pull, you need to press. You press that lever. Yeah. And pull. And when you pull, it's just unlock, and then you can pull it back. That's how it works. And that is the next part of the high current circuit, and those components will be the subject in the next episode of the Mega Power series. I hope you enjoyed this time, and see you later.